All right, today we're not as sick as yesterday, so we're coming back live to you from sixth hour. Five. You guys are sick. Now they're sick. Today we're going to do inequalities. So what do you remember about inequalities that are different than equations? Less than or equals, that's good, yep. They also have like tons of answers, not just a couple. So we oftentimes represent our solutions by pictures or number lines. Okay, so we're going to do two things. We're going to look at inequalities in two variables with a graph and inequalities with one variable, quadratic inequalities with one variable as solving with algebraic methods and number lines. So here is just a cutout from the book so you can have a look at what this is saying here. I don't think I can scroll up or down. Oh, I can. So this is some stuff just straight from the book. You'll see it's kind of a real world application situation, and then if you have two variables, an inequality with two variables, y and x, you'll see it looks just like a graph of a parabola, except for you have one of the sides shaded, just kind of like what we did with linear, where we had linear inequalities. It was either dotted or solid line, shade above or below, and this is the same concept, but just with a quadratic or a parabola. All right, so if we have, let's just say we have one here, and we have y is greater than or equal to x squared minus 7x plus 10, and we graph that, how would we know where to shade? And by the way, it's a solid parabola because it's greater than or equal to, right? So what did we do before? Yes, Dave?
Try 0, 0.
Try 0, 0 or an easy test point, right? So if I check 0, 0 and see if that is true or false in the original inequality, that will tell me which side to shade. If it's true, I'll shade that side. If it's false, I'll shade the other. So if I put 0 in for y and 0 in for x, I get 0 is greater than 10. And we know that that is not true. That is false. So because 0, 0 makes the inequality false, I'm going to shade the other side of the parabola, which is the inside, I guess you could call it, of the parabola, or above the parabola. Okay. All right. Let's try another one. This one again is solid, not a dotted parabola. 0, 0 is a possible test point. When would 0, 0 not be a possible test point? When it's on the, it's not a line though, it's on the parabola. So it's not on the parabola, so we can test. If we put 0 in for y and 0 in for x, this is going to be 0 less than or equal to 14, which is true this time. So because it's true, then I shade the side that 0, 0 is on, and that's going to be outside of the parabola. Or I guess you could say like it's below the parabola. Light? I said light, but I meant to say right. I can't talk today. I'm still feeling a little sick. Are we good? Okay. Now we'll look at solving algebraically, and notice now we don't have a y in the equation, we have just all x. So this is kind of like, when we solve setting y equal to 0 and we solve a quadratic equation, we put 0 in for y. So in this case, we want to also know when the equation is equal to 0, because that's how we use a lot of our methods to solving. And in this case, if I were to solve this equation, I would solve it by factoring, because this one factors easily, or hopefully easily. And we have x and x, two factors of 6 that give me a middle product sum, I guess, outsides, insides of -5 would be 6 and 1, and the minus goes with the bigger number. So my solutions then to this equation would be x equals 6 or x equals -1, right? If I were to graph that on a number line, it would be kind of silly because it would just be two dots, right? It'd be like, oh yeah, all right, the -1 and 6. Yep, there's your solution. It's just those two dots. Right? I mean, we really don't do a number line just when it's an equation because it would just be dots. But if it's an inequality, then yeah, we're going to need to use a number line. Oh my gosh. There we go. So if I'm going to solve this inequality here, I want to know where this is going to be true or false. So is it going to be true or false in between there? Or is it going to be outside or on the outsides of those? So it's either going to be in between -1 and 6, all the values for x in between there, or on the outsides. So what's the best number to check again? 0. So let's check to see if x equals 0. That lands in between there. And if I put 0 in, I'm going to get -6 is greater than 0. Is that true or false? That is false. So if it's false in between, then it's going to be true on the outsides. So my solution here is going to go like that and like that. So it'll be all numbers less than or equal to, or wait a minute, it's not equal to, is it? I have to make an adjustment here. I colored them in because I was solving the equation earlier, but really it's not an equation, it's an inequality, and that inequality is not inclusive because it's just, see, it's not, I put a number, okay, Junior. Anyway, it's just strictly greater than, so I need these to be open circles. Okay, because the actual value does not include, the actual solution does not include -1 or 6. All right, phew. Now the final answer is going to be x is less than -1 or x is greater than 6. Have to write it in two separate parts because it's a disjointed solution. There's a space in between there. So it has to be an or. If it's an and, you can write it all as one. All right. Okay, wake up back there. Wake up. Okay, next one. It's a little more fun. Ooh, it's not set equal to 0. So make sure you got to move that over there, okay? So we have 2x squared plus 13x plus 20 is less than or equal to 0. Okay, I want to know where it's equal to 0 because that's going to be where my boundaries are. So my boundaries are going to be colored in this time, so I'll just put some generic boundaries down there. Okay, they're colored in because it could be less than or equal to. Does this one factor? I think it does. Let's see, 2x and x. Factors of 20. I'm going to start with the close ones together, 5 and 4. And I'm going to put the 5. I'm going to actually put the 5 there and the 4 there. I think that's what works. Yep. Because now, and that works because my outside products gives me 8x. And my inside products gives me 13. 13. I'm malfunctioning today. 5, and so that gives you a sum of 13 crepes. So that gives you a 5, and that gives you an 8, and together makes 13. So the two values are going to be -4. That makes this factor 0, and the other factor that it makes 0 is -5/2, which is -2.5. Okay, whew. What's a good number to check to see if it's in between or on the outsides? Sure, we can do 0, but 0 is not always in between, so 0 is over here. So if I check x equals 0, I'm checking to see if it's true or false on the outsides. So if I put 0 in there, I get 0, 0, and then 20 is less than 0. So is 20 less than or equal to 0? That's going to be false. So if that's false, it's false on the outsides, and it's true on the insides. So if it's true on the insides, then we need our solution to look like this. Okay, it's a conjunction, and so all x values in between -4 or -2.5. Yay, nay? All right, I'm going to pause it and I'm going to give you a minute and a half to do this next one. So if you tried that at home, we're back now and there's the solution, and we just had a good little question. Was you always put the smaller number on the left side, right, of the inequality like that? And the answer is yes. Yep. So you want to have the smaller numbers on the left, like a number line. If you go left, everything keeps getting smaller and smaller and smaller. Okay. The next one is not such a nice one. The next one, we have an equation that is not going to factor. And so, of course, if this doesn't factor, then we got to do the old employ the DNF-UQF strategy. Does not factor, use quadratic formula. So if we crank that out, we have the opposite of 3 plus or minus the square root of 3 squared minus 4 times negative 2 times 6, all over 2 times negative 2. Oh, I am so malfunctioning today, it's ridiculous. Yep, 2. So now we have a 9 minus a negative 48, which ends up being a 57. So this is negative 3 plus or minus the square root of 57 all over negative 4. This kind of bugs people, I think, with this negative there and the negative there. Okay, but if you have a negative there and a negative here, like a negative 3 over a negative 4, and I break those apart, I'm going to have this. Negative 3 over negative 4 plus or minus root 57 over negative 4. But no one would ever write negative 3 over negative 4, would they? That's silly. You would just write positive 3 over 4. And if you have plus or minus, that takes care of the positive and negative anyways. So you can just forget about the negative on the bottom and just write that as 57 over 4 like that. So it's 3 plus or minus the square root of 57 over 4, or 3/4 plus or minus 57/4. Now, since we have to put this on a number line, I'm going to take a little calculator and I'm going to take the square root of 57 divided by 4, and I'm going to get approximately 1.89. So this is like 0.75 plus or minus 1.89. Okay, well, when you add 1.89, you're going to get about 2.64. So 2.64 on the high side. And then on the low side, you're going to get a negative number. You're going to get, what is it, 0.75 minus 1.89 gives you about negative 1.14. And so when I'm putting these on the number line, it's important to kind of know what those values are so I can determine what test point I want to use. So they're going to be open circles. This one is going to be, if I write it in exact, 3/4 minus root 57/4. This one over here is 3/4 plus root 57/4. And is 0 in between there? Could I test 0? I could, and that would be in between. And so if I put 0 in, I'm going to get 6 is greater than 0, which is true. So the solution is all the values in between those two irrational numbers, 3 plus or minus root 57 all over 4. Okay, so then your final answer is just going to look like it does with integers, but you're going to have these fun values like 3/4 minus root 57/4. You can leave them as like irrational numbers, like radicals. So greater than, so x is going to be greater than that, and then less than 3 plus. Yay. Look at that, all under 15 minutes. We'll let you try the next one, and then I will put a solution up here in just a second. So you can pause it, try the next one if you want, check it when you're unpaused. So after another fun time with quadratic formula, we end up with this as our solution. It was true on the outside, so I have to write it with the or. Okay, and so it's two different inequalities. Either x is less than or equal to that stuff, or x is greater than or equal to that stuff. All right, high five, good times. Here's your assignment, and have fun with that.